nTopology is meant to be used to complement and work with your current engineering tools, so we don't typically start from zero. Instead, we import into nTopology things like CAD or mesh files that we have already designed, or even in combination with other engineering data and test results, for example from structural analysis and optimization, or CFD data. We then use these inputs as references to create complex geometry and designs that are difficult or impossible to do elsewhere. We can export what we've done in nTopology into files or data for the next design iteration, for manufacturing, or as files to be further analyzed or optimized in external analysis software and solvers depending on your specific applications. Essentially, what we do in nTopology is not creating a specific part, we are building a process that can work on any part. This means that whatever we build can easily be reused and automated. This is possible because of the way that nTopology represents geometry. The legacy method of describing geometry is through boundary representation, or B-Rep for short, where faces are created and joined together by edges to separate the inside and outside of a solid part. nTopology works quite differently. It describes the same geometry or volume using a mathematical equation. This is a much more lightweight way of handling geometry data, and because we're only working with equations, we're able to very quickly generate complex structures without adding to the file size. nTopology stores these volume-defining equations behind the scenes, and with given input parameters, it computes these equations and then renders out a visual representation on the screen. This visual representation is called the implicit body, which is nTopology's native format. There is an implicit field associated with every implicit body, which allows us to visualize these behind-the-scene equations. In the next lesson, you'll learn more about these implicit geometries and implicit fields.